Hi guys, this is the third video on the inverse trig functions, and this one is going to concentrate on the tangent function. So in front of you now you have a graph of the tangent function, y equals the tangent of x, and I hope you remember from when we graphed this in class that from negative infinity to infinity, if that's what my x's are, except for the odd multiples of pi over 2. Okay, the x's are not allowed to equal odd multiples of pi over 2 because the tangent function is not defined at the odd multiples of pi over 2. And we took a lot of time and discussed that in class when we were graphing the tangent function. So be sure you go back and look at that if you need to. This is the domain of the tangent function. And the range of the tangent function is all real numbers from negative infinity to infinity. That's my range. Okay, is y equals the tangent of x 1 to 1? Well, hopefully by now you can quickly look at this and say no. Horizontal line test shows me that it is not 1 to 1. So based on what we've watched already, we know we have to restrict the domain. So the restricted domain for the tangent function is from negative pi halves to pi halves. Now notice, I hope you will see that this is the same restricted domain that we used for, not inclusive. This is the same restricted domain that we used for the sine function, except for the sine function we could include the endpoints, and with the tangent function we cannot include the endpoints because the tangent function is not defined at negative pi halves and pi halves. So this is non-inclusive here. Okay, what does the inverse tangent mean? Well, it means the same thing as the other inverse functions. We read this as y equals the tangent of x, but it means y is the angle whose tangent is x. So let's look at it. Y equals the tangent inverse of x. Again, y is an angle that we're looking for, and x is the value of tangent. So y is the angle that we're looking for, and the x is the value of the tangent. Okay, now remember, we have to be within the restricted domain of negative pi halves to pi halves, non-inclusive. All right, just like with the other functions, the tangent inverse and the tangent undo each other as long as our angle is within the restricted domain. So the tangent inverse of the tangent of u is equal to u as long as u is between negative pi halves and pi halves. And the tangent of the tangent inverse of v is equal to v for any real number. So this one will always be true. The characteristics of the tangent. Y equals the tangent inverse of x. The domain of the tangent inverse becomes the range of the tangent, and that's all real numbers. And the range of the tangent inverse is the domain of the tangent, and that's between negative pi halves and pi halves. Again, this is because they are inverse functions, so the domain becomes the range becomes the domain. Here is your picture of the tangent with its restricted domain. Here's the picture of your inverse tangent. Here's your y equals x. Same thing is happening here that has happened with the other two. The reflection across the line y equals x. Now, how do I find the exact value of the tangent inverse? I do it exactly like I did before. I'm looking for an angle whose tangent is negative square root of 3. I'm going to be looking in quadrant 1 and quadrant 2. I'm sorry, that's not right. Quadrant 1 and quadrant 4, because pi halves is here, negative pi halves is here. So if I'm looking for an angle who has a tangent of negative pi over 3, I know it's not in quadrant 1 because all trig functions are positive. It has to be in quadrant 4. And remember, just like with the sine in quadrant 4, we're going to be looking for negative angles. So this is negative pi over 3. So my angles here are negative. My angles here are positive. All right. If you have questions, please post them to Edmodo, and I'm going to answer them every night. Hope you all are doing great.